Okay, so I'm here to talk about building your own lightsaber so we can all be Jedis or something like that. Anyway, I have built a bunch of tools over the past 2 years for my classes, and so I've shared links to some of them on the mailing list, and a bunch of folks had questions about that, so that's why we're here. So I am gonna I have some slides, but I'm super flexible on like digging deeper into some topics or less deep into whatever. So we're gonna start. Oops, let's see. Does this work? There we go. Okay, so building a lightsaber looks like this. Thanks, Dali. Actually, that's a little bit dark. Let's see if we can try again. There we go. That's what we're looking for. Happy Jedi making a lightsaber. That's okay. So I assume
That's great.
you may or may not know the Star Wars lore, but the true Jedi has to build their own lightsaber. That's part of becoming a Jedi. Luke starts out with his hand-me-down, and by Return of the Jedi, he's built his own. Now he's a true Jedi. So less flatteringly known as NIH, not invented here, the need to compulsively build your own stuff. Okay, so I want to start with some introductions. So if everyone can just pop in the chat and just tell us how many years you've been teaching, how many years you've been taught CSA, and anything you want to share about your programming experience, just so I have a sense of who's in the room. You can just throw that in the chat now. And I'd encourage people, if you want to go on video, it's fine, so we can all see your faces in little grid, but if you don't want to, that's also fine. All right, we got 10 years teaching CSA. 1 year teaching CSA. Shout out Padma, me too. Ex-software engineer, 15 years, 30 years, CSA for 3, principals for 6. Kate, we all know, CSA teachers celebrity. 3 years CSA, 34 years of teaching, 2 years teaching CSA, physics, comp sci. Cool. All right, let's. Three years, second year. Okay, so you have a pretty wide range. I'll just tell you a little bit about myself, answer these same questions. So I just finished my second year of teaching all told and my first year of teaching CSA. But that was after a 30-year career, basically as a software developer, almost 30 years. So I first worked on the web at Mother Jones Magazine. I actually went to Mother Jones to be a journalist. I was going to like an intern at Mother Jones. I was going to like fact check for the magazine, but they had a website in 1990, which was really new at the time. I was like before Wired magazine had a website. Or maybe by then Wired had one, but we were there first. And so I learned to program working at Mother Jones, working on the web. And then between then and when I became a teacher 2 years ago, I worked as a programmer and later manager at some startups, at Etsy, at Twitter. And then my last job was running the engineering team at the Democratic National Committee during the 2020 cycle. And that was pretty stressful. So then I was hanging out and I started volunteering as a teacher, or volunteering in the classroom at my local high school, and then figured out I could get a credential as CTE. And so I did that. And so now I'm a teacher. And so this year I was in my first year teaching CSA. I also last summer started collaborating with Beryl on CS Awesome, probably prompted a little bit by the same inclination that leads me to like write all my own stuff. I was like, I gotta change this book, because we use CS Awesome. The old teacher at my high school used it. I'm like, that's great. I want to use it, but I also want to make some changes. And Beryl was very gracious and was like, well, just make your changes and maybe we'll merge them in. And we did, and it was great. So I really enjoyed working with her on that. I also knew I would not survive a year of teaching Java without an auto format button. So I added that to Runestone. And then I was ready to teach. Previously, I'd written some other books, and you can find them on Amazon or whatever. And so that's me. So I'm Yes, that's the, I'm coming to this relatively new as a teacher, but I used to teach. I taught some at Berkeley Extension, so totally new to it. All right, now in the chat, um, let's get some questions. If there's particular topics you want me to cover, you can peek ahead if it's, or actually you can't peek ahead of the slides. I'll post a link to the slides. Let's see if I can do that in the chat in case you want to follow along at home. Here's the slides. But put anything in the chat that you like hope I'm going to talk about. I'll try and guide by that. And as we go along, I'd encourage you to just put questions in as they come up. There's kind of enough people here that we probably don't want people unmuting and shouting out all the time, but I have the chat window open and I can try and answer them on the fly as I go. Okay, how to set up GitHub. That's a good one because I didn't really make a lot of slides about that, but I can definitely talk about it. Okay, so just throw your stuff in and I'm going to get going because we got a bunch of stuff. So why did I have to build my own lightsaber? Well, basically because I'm a control freak. I like things a certain way, as Beryl can probably attest. And also because I really love programming. So this is a great job for me because I get to teach and hang out with kids, but I also get to spend actually quite a lot of time, like more time than I did as a manager for sure, just writing code. And I'm mostly doing it by myself. And so I don't have annoying coworkers and life is great. So here are some things I built, and I'm going to go through these at varying levels of detail. So there's the class website, which is what some of you have seen because I posted links to various pages on it. Just so you know, a lot of the website you can see, a lot of the content. Some of the actual interactive stuff you can't because you have to have a GitHub account and be in the GitHub organization for my high school. I used to have an anonymous mode, but then actually the thing that made me switch it was one of my intro kids I noticed was doing problem sets, not logged in, figuring out all the answers because it was like unit tests until he got them all right. And then he'd log in and paste in his answers, like looked like he got them all right the first time. So I was like, no, I want to see your progress. So I made them log in. A journal website, which I built last summer for this year, which is where I have kids write like weekly reflections. A help queue, which I built 2 years ago, which is basically just for managing a queue of requests to help people in class, because a lot of our classwork is kids working on their stuff, and I wander around and help them. And a rubric grader, which I built at the end of this year for grading assignments that aren't auto-graded. And so I'll show you a little bit of all of these. And I'll talk about, these are all, or not all of them, but the first two are definitely intimately tied in with GitHub, particularly the class website. So I'll talk about that, but I can talk more about how to actually use GitHub in teaching. Okay, so the first thing is the class website. You can, so this link will work. Many of the links on the site will work for you, whether you're logged in or not. And yeah, Jeffrey, to answer your question about security, it does not, like, they won't, or at least I know my school district, there was a point where I was trying to like get us signed up as whatever, GitHub has some GitHub for Education thing program. And I was talking to our tech people at the district and they're like, well, they would need to sign this thing. And GitHub were like, no, we're not going to sign that. And the problem was like some trackers, tracking pixels on their marketing pages. According to the school district, that's no go. So I've just been using it. I told them I'm using it, and it's neither on the approved technologies nor on the disapproved technologies list. So some districts definitely might be more on top of that. I've been thinking a little bit about what I would do if GitHub got yanked, and I think I would be okay. I could build more stuff on top of just Git. But the website is A, basic content, B, including slides like these. So these slides are actually on the CSA website now. A simple coding environment, which was actually the first thing I wanted when I went to build it. Actually, I built it for my intro class. And then using that environment, I can make assignments and assessments, which are really the same thing, just depending on whether I grade them. And also there's a calendar, which I'll show you. And code presentations I built at the end of the year, and they're kind of nice. So this year used the website tried to use it as kind of the central place, but I still had Google Classroom and also still had our student information system for grades. Next year, I'm going to see if I can cut out Classroom and just use my website because it was mostly just confusing for the kids. Okay, so how did I build this website? This is just like, what technology did I use? So it is a static website. So some of you may know what that means, some of you may not. It basically just means that at the point that it is served, when kids are browsing it, is just a bunch of files served up by this company, Netlify, which basically watches my GitHub repo. And whenever I push to a specific branch, Netlify pulls that branch down and runs the build scripts that are in the repo to produce a bunch of files and then publishes them to the web. And it's very nice because if the build fails, they don't deploy it. So it just stays on the old version and tells me that it's broken and I can fix it. So it's really easy for me to make changes, check them into, commit them to Git, push them to GitHub, and they go live in a few minutes. And because it's static, there's nothing really to break. It's not doing anything. It's not writing to, there's not a database that could get filled up or that could crash or really anything. So in some ways, that's like the best thing you can do if you can get away with it. It seems more dynamic than that because there's client-side JavaScript and it talks to the GitHub API and stores stuff in GitHub. But so the GitHub has to continue to work, but I am pretty confident that their site reliability engineers are on the job and it will keep working most of the time. Banware1 is asking, can the GitHub site become password protected, non-static? I don't know if you mean like my site. Maybe say more in the chat. Any site. So GitHub has a thing called GitHub Pages, which may be what you're talking about, that lets you basically do something similar where you basically check stuff into a GitHub repo and then GitHub can actually build a website and serve it up for you. I think the reason, well, I didn't, at the time, what I knew about it, it seemed too limited for what I wanted to do. I think lately it's gotten better and I might be able to use it. There is, however, an authentication step that I'm going to talk about in a sec. That I'm not sure I can handle with GitHub Pages. But asking about password protected, as I alluded to, oh, dang it. This feels like these slides are just, oh, there we go, look, slightly out of date. Okay. Oh, here is the bit. So Netlify also handles this authentication dance. So that's the other thing the website does, is when you connect to certain pages on the website that need to access your stuff on GitHub, you have to authenticate. And so OAuth is the terrible, confusing standard way that allows a website built by me to let people who are using my website authenticate to GitHub so that code running in their browser can talk to GitHub as them and do things like access their repositories and lets the code that's running in the browser know, like, okay, this is this GitHub user. So OAuth is the way that this happens. There's this weird dance that's like you gotta redirect them and then they get redirected and then bounces around and eventually they're logged in. Every time I have to implement it, I have to figure it out again. But Netlify has a thing that handles that for you. So that is how I do it on this website. And so this website, the simple part is just the content. So whenever I just want to put a page on the website, I just can put it there and there it is. Whenever I put up this exam page before the exam and has links to other things. So that's just normal web content. Oops. Okay. Slides are what we're looking at right now. They're built with reveal.js, which is a library for generating nice slides from HTML. There's I'm spacing on her name. She was like an adjunct at Cal for a while. She's done a bunch of uh, computer science pedagogy stuff, and she has this great essay about why you should use HTML for your slides. And there's just like a lot of stuff you can do, but obviously the more comfortable you are with HTML, the more that might be, but you can really make some nice slides, and Reveal.js is a library for doing it. I actually write them in my own text-based markup language. So like I wrote all these slides this morning, and it's just a big text file. And then I have some code that generates the right HTML, and then Reveal does the rest and makes these slides. So it's a lot easier. I can keep them in GitHub, but it's a lot easier than making like Google Slides or PowerPoints or whatever, because I mostly just write text. And that's the thing I like to do. So yeah, asking about how I store the organization of the site is largely determined by the site generator 11T, which I mentioned back here, I think. So it has a kind of point of view about, it's kind of built, I think, for making blogs or something, where you have a series of articles. They get that each article that has a certain tag gets put into a collection under that tag, and then you can generate, this page has a list of all the things with that tag. So if we look, for instance, at, actually, I should have done this to start with, for those of you who haven't seen it, the website, like this is the website, this is the homepage. And so for instance, this slides down here is just a list of all the slides, and it got, as I wrote slides this year, they got added in chronological order based on the metadata that I included in the files where I wrote the slide. So like my first slide, these might not be exactly in order. I don't think I started with objects. Oops. But things are a little bit in flux at the end of the year. Okay, so but anyway, so the 11T makes it really easy to make lists like this. I did the same thing for the assignments, is a different collection. Assessments is another collection, and then the rest of this is just normal content. So you can like basically write templated HTML, and it fills in stuff. Okay, so that's the content and the slides. The coding environment is actually kind of the key reason for the site. I want to have, and it started for my intro class, where I wanted to have a really easy way for my intro students, or mostly freshmen, and we're using JavaScript, to just be able to write some code right away. And I hate Replit, basically. Like even before this year, when they kind of screwed us all, like I just didn't like Replit as an environment. And for JavaScript, it's really easy because the browser speaks JavaScript. So I just wrote a website that let them edit JavaScript in the page and then run it in the browser, and everything was great. And then last summer, I was like, oh God, I got to figure out how to do this with Java. So I figured out how Runestone did it, and did basically the same thing, which I'll talk about in a sec. So, but the goal was to provide an immediate place where students could write and run code. And I wanted to be able to, and this is part of why I wanted my own thing rather than something like Replit, is I wanted to be able to provide various frameworks for different kinds of assignments, and we'll see those in a little bit, such as assignments where they write code and then we run unit tests against it, or they write code and on the back end it actually generates the graphics like an image and sends it back, and it gets displayed in the browser. And so I can talk a little bit about how that worked. My plan from the beginning, and which I did in fact do, was as we got further in for more complex projects where you need to have multiple files and whatnot, to just use GitHub code spaces. But so let me actually talk a little bit now about GitHub, because I know a bunch of people have questions about that. So actually just, I don't know, well, I can't, I'm curious how many people regularly use GitHub. Maybe just throw a +1 in the chat if you use GitHub for anything, just like for yourself or anything. And you can throw a -1 in if you really have not used GitHub. Okay, so some of both, -100. Okay, so some of you have experience with it. All right, so Git is just a back off a sec. So Git is this tool. It's version control. So hopefully you're have some idea what that's about. But basically, as you're working on a bunch of software, particularly when you're working in a team, people are making changes. You need to track all of those changes. And in a team, you need to worry about how to like combine changes that different people did that may conflict with each other, or there's a whole bunch of stuff in like software development that problems that a version control system like Git is designed to solve. So Git is just a tool that provides that facility, and it's designed in a way to be it's called a distributed version control system because everybody has their own copy of the full history of everything, which is quite nice. GitHub is a company that provides basically Git as a service on the web. And so despite the fact that Git was designed to be sort of distributed and decentralized, GitHub then becomes the central place that hosts the sort of source of truth version of all your repositories. Even though when you use Git, you're going to have a complete copy on your local machine, the way you share code with other people is you push your changes from your local machine up to GitHub. And then GitHub provides a lot of amenities on the website for dealing with that code and for reviewing it. So you can push changes to GitHub, and then you make what's called a pull request, which is basically packages up all your changes and lets you write some description and then shares that with your teammates, or in the open source world with the maintainer of some project that you want to contribute to. And then they can see the changes and they can leave comments and you can reply to their comments, and eventually they can approve it or not. And then if it gets approved, then you merge it and it becomes part of the project or the product, whatever context you're working. And so on top of that, so that's just version control, but you're still running the code on your local machine, whatever. GitHub code spaces are basically like a pro-style version of Replit in that GitHub hosts a virtual machine, which is at the point it started connected to a GitHub repository. And so you spin up this virtual machine, and then you basically have a Linux computer that has access already to your GitHub repository. You can make changes to it. You can push them to the main GitHub, like the central web repository, whenever you're ready, just like you were working on your laptop. But the computer is all running in the cloud. And if you shut that browser tab, it goes away, but it still persists, and you can come back and start it up again later. So it's just a very nice environment for the same reason Replit is for students, if we want people to be able to work in a computer lab without having to install a bunch of stuff on the computer and then go home and work on the same stuff is probably the real winner. Whereas if they were working on, say, Eclipse or whatever on a Mac in the lab, and they forgot to push something to GitHub, then when they went home and tried to work on their computer at home, they wouldn't have access to anything they were working on. So for a bunch of reasons, we wanted to use a web-based thing. And so Codespaces is basically like an industrial strength version of Replit. I frankly do not know exactly what the pricing model is of Codespaces anymore. I got basically comped free Codespaces for our organization by a friend of a friend who works at GitHub, who I think has left GitHub. And someday they may notice and be like, hey, you got to start paying for this stuff, which will make me sad. But I think they give everyone now some amount for free. So I don't know. I haven't had to really dive into the economics of it. But if you're interested in using Codespaces, you might have to look and find out how much it actually costs. Okay, so Codespaces also better than Replit. One of the selling points is the environment it gives you. The editor is Visual Studio Code, which is basically Microsoft's, not their old bloated IDE, but their lightweight text editor, which is sort of growing into be an IDE, but which lots of people use for real. Like former colleagues use it all the time. So it's like a real programmer's editor, and it's written in JavaScript. And so it can run in the browser. And so it's Codespaces just runs Monaco is what it's called, as the editor as you edit the files and code spaces. Monaco is also an open source library. My website also uses Monaco, so that the environment I give my students early on is going to be the same one in terms of the editor as when they get into code spaces. So that was the other selling point for me, was that I could have the same consistent environment between my website and then the big boy, big girl version when they get to code spaces. Okay, so here's some examples. Here's like the simplest example, first like proof of concept. So you can see here that the first thing it does is ask me to log into GitHub, because this page requires access to a GitHub repository so that it can fetch some code. I guess in this case, you see this. Oh yeah, this one, right. So this is like, I've worked in this thing a lot. So basically it just has all the revisions that I've ever made to this code, and I can go back to them if I want. Here it is. This is the editor. So this is basically Visual Studio Code. And if I run it, assuming everything is still working, it ran this code, which printed out some stuff, and the output came out over here. And you'll notice that it says 76 characters in input. The input came from this text box down here. I also could have fed in a file. And if there had been errors, like standard error, would have come out in this box. So this was mostly just like, let's just do whatever we want. So we can say, add system out println hello Zoom, run it. And there, new output. Okay, so that makes it easy to like test. And this is reasonably fast. It's like on par with Runestone because it's doing the same thing as Runestone, which is shipping the code out to another server, which compiles it and runs it. Here's an example of an assignment, which I think I set up, roughly speaking. When I make these pages, part of what I make is the code that gets put in this editor to start with. So this was an example of an assignment I gave them. This one is a little narrow, but where they were going to write a Mad Lib, and I was giving them some variables and some useful methods, and then I wanted them to fill in these to-dos. So this is similar to like things in Runestone, where I gave them to-dos that they needed to fill in. And I think if you run it as is, it works and does a little simple Mad Lib. So this is like an example of an assignment that I would give to just, in this case, just to have them play around with it. There was no particular goal, but I would walk around and give them feedback about it. And as I mentioned, there's another kind of environment, which is a graphics environment where the code you write is actually implementing this interface. And this is early in the semester. I'm just like, don't worry about what that means. But what really matters is that in order to implement this interface, you have to have this draw method. And this is just using the actual Java graphics libraries in Java auth. And when you run it, it submits the code, but instead of getting text back, we get an image back. And what this is actually doing is the server is still just generating standard output, but what the standard output is an image tag with the image basically in line as data. And then the JavaScript that handles this knows to like take that image and insert it into the page. And so there's all kinds of stuff. I think I picked out a few good images here. Yeah, maybe that's where it started. Some gradients. I was just playing around with stuff. Also collapse these things to get more space. Okay. So those are some of the, and we haven't looked at the unit test environment, but we now will. So assignments and assessments, a lot of my assignments, a boot up is like a bell ringer or a do now or whatever you call it. This one is done. Probably when this file started, I'll just run it once so you can see what it does. But when this, actually, let's see, we go way back to the beginning. No. What happened? No, I don't know. I don't know why I don't have the beginning. All right, so if I run this, now what's happening, it's shipping the code off, the code is compiled and run, but behind on the server side, it's running a bunch of unit tests against this code and checking each of these methods. And these are the tests, and it shows you what the arguments were and what we expected. And so in this case, it's actually checking various like qualities of the results rather than the specific results. And the way this thing works, oops, if I like take one of the methods out, it still works. Oops, well, it would have worked. What happened? Oh, I'll just change the name so it doesn't match. And you'll see that this box is gray because there is no method to be tested at all. So actually, when the thing started, they probably got something like this as the starter, and if they run it, they just be like nothing, and all this is describing the methods they need to write. This particular assignment was actually grew over the week. Probably the first day it just had one method. They would write that one, and the next day I would add the next method because it builds in a progression. But the idea of these unit tests, I write the tests in Java, and then they test their code. All right. A different style are when we get deeper into like unit 5 and they're writing classes. I don't really want to test, like, I can't test that the methods do certain things. I actually want to test that they write like a class that has a certain shape. So in this case, the things I want, and again, it kind of is a progression, like write a class named point. And so if this started out with just empty, they would need to write public class point. Public class point, and run that. And the first test should pass. Right, so the first class passes because there is a point class defined and it is public. But all these other ones are failing because they have other requirements that haven't been met yet. But if we go back to the one that was full, they're all passing because now there is a main method that is, there's only one of them and it's public static, and it prints something that starts with hello world, and then we've got some instant variables that I asked them to write in a constructor. So this was a way to test, like, do they understand the vocabulary of, write a constructor that takes these arguments or whatever. I also have a thing for building multiple choice questions, and I'm going to come back to some of these questions in a second. So sometimes I give them tests that are just multiple choice rather than use a Google form, or probably I could build this in Runestone, but I don't actually know how to use Runestone that well. I just do it here. This is also being saved to their GitHub repository as JSON, so it makes it easy for me to download and analyze with scripts. So this is just an example of one question out of many. This actually had a mix of multiple choice and freeform answers, which obviously are a little more of a pain to grade. I have some automation around that. And then that was that. And this show answers here is because I have posted a key. And so once the key is posted, you can tick that box on, and it will either give you a canonical answer for freeform or tell you to show you what the right answer is. All right. Oh, come on. All right. The back button isn't quite working. All right. All right. Oops. Too lost in the all those or some word pages. Okay. Sorry. Okay. Saw the freeform answer. Let's look at some questions over here. All right, someone posted some useful information about pricing. Can I create different Java classes? So in my environment, it's just one class at a time, other than that you can make like non-public classes in the same file. And I mostly chose to live with that limitation because I didn't want to build a UI for like multi-file editing. And I figured by the time we get to multiple file projects, that's when we move to code spaces. So all of my stuff is built around the student is writing one class, they're working on one file. Yes, Nolan, your question, can you do a GUI with Swing? You can. I didn't really think about demoing that, but I figured out late in the year that it's actually pretty easy to set up code spaces so they have essentially a little X windows that runs in the browser that displays a GUI. And so once I figured that out, that was the only thing that Replit did that I didn't know how to do at the beginning of the year. So then you can write Swing apps, I assume Java FX. I just had my kids do swings. And that was great because then they could, they love to write GUI stuff. And the graphics environment was an attempt to give them an early taste of something that was not just text, but obviously making a real app that has buttons and animations and all that, which is so easy to do in JavaScript in the browser, is more painful with Java. So that is now totally a thing. I don't know about GitHub Classroom on a different domain. Yeah, okay. I can show you the code for the test cases. It's pretty hairy. But I'll remind me of that a little bit. And then, yeah, zombies, doubles or zombies. Yeah, but so as Beryl says, the Job server can't do anything. All the Job server does is compile, run your program, and send you the standard output. So it can't, you can't even have a text-based interaction with it. There's a one shot, you get some stuff back, and when you could maybe build something where you like ship state, I don't know, that'd be a nightmare. So, but once you got code spaces, you can do all those things. All right. And then one of my favorite tests that I did this year, using the graph. Now, this one was a bit of a bear to grade for reasons you'll see in a second. But the assignment was to draw the flag of the United States. So I'd given them the graphics thing. And this was really a test of Unit 1. Do you understand how to use ints and doubles properly? Because the graphics in Java are int-based because pixels are, atomic. And so they're measured in ints. But to do the math, to lay out a flag, you need to do floating point math. And so I gave them the actual specification of the flag. The US flag is like almost unique, I find, in flags, in that it is made of very simple geometric objects, and it has a in-law specification. And so it is reasonable to expect students to be able to make a flag that is properly proportioned and all the parts are properly proportioned, and even properly colored, because there's almost, not in law, but there's a Department of State recommendation on the colors. And so I said, make a flag. And the trick was that part of the graphics environment is you run the code and it ships to the server the width and height of this area where the image is going to go. And so if I run this code, it draws a flag. Now, if I were to change the size of my browser window, like put it on a smaller screen, so that the aspect ratio changed, it might or might not fit. This code, which I think this is my code, it would work. It would always fit it to whatever, if it's narrower than it is tall, it would just make the flag really short, so it would fit in the middle. But a lot of kids, either wrote it with exact specific concrete coordinates, and then it only worked in that one size window, or they managed it, in one dimension, but not the other. So the goal was for them to write code that would draw a flag that is correctly proportioned and always is like 90% of the size of the largest flag that would fit in the window. So, and then I would just test their code by dragging the window to make it smaller and running it again. And then they'd be so sad that it like looked all messed up because it was going off the screen. And we spent like, I think we spent like a good week on this. I ended up having to grade it sort of based on like a series of progress. And I had to like look at their versions and eyeball it to see if they were hitting all the points. But it got pretty easy to see, like, are things proportioned right? Are the stars laid out right? So that was a fun project, I thought, at least fun for me. I think a lot of the kids enjoyed it too. But it's just the kind of thing. I had this graphics environment. I wanted them to do something with math that wasn't just like the area of a circle or something. I had an assignment early on where they just did a whole bunch of geometric formulas, and many kids hated it because they hate math. But this was at least like use math to make something that looks good. And so that was, and if I had had my rubric server when we did this assignment, my life would have been a lot better. So we'll get to that. So what is actually going on here? Every student has a GitHub repo in our GitHub organization. So I don't actually use GitHub Classroom. So unfortunately, I won't be able to give you a lot of insight into that. I just use GitHub. I made a GitHub organization called Berkeley High CS, and that's the one that got comped the free code spaces. So we just had the one organization, and then I make GitHub teams, which are teams are just collections of users within an organization. I make a team for each section. So I have like my CSA period 2, CSA period 5, and labeled with the year because it's this year, and so next year will be 2024. And then I add students to the GitHub teams, and I'll talk later about the journal server is actually the thing that sets them up in that, and creates their repo. So they'll have a repo. The repo is named the same as their GitHub username. I do have to warn them not to change their GitHub usernames in the middle of the year. Otherwise, life gets complicated for me. But so they have a GitHub repo. So that way I know there's no naming conflicts because their usernames are already unique within the GitHub universe. So their repos will be unique. And then every one of those coding environments we just looked at, you can see it in my browser, but the URL was like assignments or assessment/flag. And so that would make a branch in GitHub, which is how Git manages the sort of different streams of development, in their repo named for the same as the URL, so assessment/flag. And the code for that thing gets saved in a directory with the same name. So that way there's no real worries about code from one project or one assignment conflicting with code from another assignment because they're just segregated by their name. And so this allows me to easily get their code I can look at it on GitHub. I have clones of all of their repos on my laptop, and I just have to go and pull them all down, like get the latest changes. And then I have the complete history of everything they've done in Git. And I have all kinds of tools for dealing with Git, and I can see when they were working and see how many changes they made. Every time they hit the blue arrow to run a thing, it's making a commit into Git. And so I can see like, oh, some kids are doing like 40 changes in a class, and some kids are doing like 4. And that gives me some insight into how, the kids are doing 4 are probably spending a lot more time talking with their friends and doing work as opposed to the kids who are really trying. Also, I can see sometimes, sadly, when like on a test and kids have very, very similar code, I can go back to the history and see who wrote that code first and sort of figure out like one time I actually saw a piece of code travel like around the room in time, which was a little bit sad, but at least I could find it. So I can see exactly when they work, but also like not just to catch cheating, but just to sort of see how they're working and see even the difference between, kids who sort of write code that like always works and they build it up incrementally that shows a real sort of fluency, as opposed to kids who like splat something out that doesn't work at all and then make another random change it randomly until it works. And the kids who paste in a whole bunch of already working very sophisticated code that I think maybe came from ChatGPT, and then I ask them to explain it to me and find out if they actually can. One of the things that GitHub, the GitHub workflow, which I alluded to before, are called pull requests, where you are basically requesting that someone, either an open source maintainer or your team, merge your change into the main thing. And that's the locus of review and comment and whatever. So I did I tried to have my kids create pull requests for their work so that I could review it and leave them comments. But in practice, that didn't work that well. It's like I spent way too much time writing comments, and I'm pretty sure most kids never read. I wrote the same comments over and over again because they made the same, they had the same, they needed the same comments, I had the same mistakes or the same, suggestions for improvements. So I'm probably not going to use it that much. Maybe save it for my advanced class where they're really working on projects in a more industrial way. And I have my rubric server that I'll show you later, so we don't run out of time. Okay, and then the code execution, I've kind of alluded to. The Java code is shipped off to this thing called Job, which is what Runestone uses as well. I hacked it a little bit to serve my needs a little bit. And it's running on this service called Fly.io, which basically just runs very lightweight virtual machines. So that's great. Job sends the output back. And then I wrote JavaScript code that runs on my website that knows what to do with that output. So a given page is configured to use a particular piece of JavaScript to handle the result of executing the Java program. So it might be test results, it might just be output, it might be an image. And so now that's a place where I can, if I have an idea of a new kind, like if I wanted to have them write code that generated sounds using some Java sound API, and then ship back something that I could load as an audio file and play it, I could do that. That might be tricky. I don't know how I'd represent that, but something like that. I just made that up. Okay. I'm going to skip this one in the interest of time. And some of you may teach other classes. You may care about other languages than Java or in addition to Java. So for JavaScript, this is great, even better, much faster, fewer moving parts. I love it. But in theory, Job can handle any compiled language. Like out of the box, Job can handle, a whole bunch of languages. You could do C++. I did a proof of concept with Python. It worked great. I don't teach Python, so I never used it. But the framework is pretty adaptable because Job is adaptable. All right. This is probably not something you've seen, but I really like this thing. Makes my life good. So this might not look that complicated. This is a calendar mapped to our year, and it has some nice things like it knows about when when we don't have school and when our breaks are and blah, blah, blah. But the thing that makes this great for me is that calendar is generated on the fly from this textual outline of the class. And this outline is actually kind of a mess because I took all of the essential knowledge items out of the CDE, put them into a text file, and then mapped them to the stuff I was teaching to make sure that I was actually covering everything. But the key bits are the top level things. I specify a unit and I say how many weeks I'm going to spend on it. And then at any level in the outline, if I put a number in parentheses, that means I'm going to spend 2 days on this. And so here's setup is 2, ethics and hacking is 1. And then, so that was that. And so if we go back to the calendar, we'll see that in fact, the first 2 days were on setup and there was 1 day on ethics and hacking. And then the rest of this all just gets filled in. And when I'm developing it, the JavaScript that renders this outline will actually tell me if I've filled up too many days for the number of weeks, right? If I was filling in these 2 weeks, but I really only have 8 days because of the 2 days off, and I had put 9 days worth of material in, it would give me a little warning saying you've overfilled this box. And so I work on that, and I can make sure everything is going to fit both in the year. I can sort of see where the breaks are, so I don't have a unit that spans a big break. And it's just really nice. And so you may have gathered that I really prefer to deal with text. I would much rather write this and have it turn into that than try and write this stuff in HTML. This was not generated with Reveal. This was purely my own JavaScript that like knows how to understand this text file and generate the HTML for the calendar. So anyway, it's a little handy knob on my lightsaber. Oops. Okay. And this is a thing that I built at the end of the year so the reveal slides are pretty good, and they can even do some like code highlighting, and there's ways to mark up, like highlight certain um, certain lines, then we'll highlight those, then highlight some other ones. But you can't fit much code in a slide. And sometimes I just wanted to talk about bigger chunks of code. Just to answer some questions. The text file that I just showed you is actually not my markup format. And to answer a question from someone way back when, is my markup just my like preferred idiosyncratic way of doing things? Probably yes. It's actually a format I created when I was writing my first book. So I wrote my whole list book in this text-based markup and generated what in the end my publisher needed from that. But in the meantime, I could generate HTML. So I've used it for 3 books. All the stuff on my website is just a very simple text-based markup. Okay, but that outline was just yet another thing. Okay, so here's how we present code. The idea here is that I want to be able to sort of build code and talk about it. So this was actually an example of a test I gave my students where they were going to write a bunch of classes, and there were no unit tests. It was just, they just had to write classes. And actually I should have, let's go back. Oh, dang it. Sorry, I think I skipped. We should have seen this already. Here we go. Sorry, I skipped this one. All right, so this was the test that we're about to look at the code for. So this was an example of, it's not a multiple choice test, but one where they were just writing code, kind of like an FRQ, where there's no answer, there's no unit test for them to run. They can't even run it, actually. And when I grade it, it's just me looking at the code. So this was an example of an inheritance test where they basically gave them a series of classes they needed to write that needed to inherit from each other or not, as the case may be. Of course, I added an auto format button. So if the formatting is messed up, formats it right. But okay, so that's the test. And so then so excited about the flag test, I skipped ahead. Okay, so now here, after they all took the test, instead of individually reviewing all their code in a PR and leaving the same comment on all of them, I looked at all their code, actually graded it probably in my rubric server, and then made this presentation that I could talk about in class and say, okay, here's the first class I asked you to write. The first thing you needed to do was add this instance variable. And then you needed to write the constructor, and here's the style that we prefer, and here's the method you needed to write, and next one, and that's the class you were trying to write. And then here's the next class in it. And so this is really just like kind of slides specifically for code. So it lets me build, I can do the whole thing, I can step through it. And this is obviously designed, I just write this again in a simple text format that says, show these lines, then show these lines, and show these lines. And I know what I want to talk about as I present it. But it's also on the website, so the kids can step through it themselves if they want. It's just, you can't see it, but I'm just hitting right arrow to expose more code, left arrow to hide it, and then shift to move to the next one. And so this is, sometimes you just want to write the code in front of them, like live code it. But something like this, I don't want to type all this stuff out and spend forever fixing my typos. I just want to be able to show them what the code looks like, so I can talk about it. Oops. Okay, so that's that. All right, we have about half an hour left. The language is used to translate text to JavaScript. So everything on the website is written in JavaScript. The test frameworks for Java and the Java execution that runs on Job is perhaps obviously written in Java. So you have to write stuff in the language that you're using on the Job side, but building the website is just web technology, which these days is JavaScript and HTML and CSS. All right. The journal website actually started life. It used to be that, like in my first year with my intro class, the class website itself would walk the kids through setting up their GitHub, because most kids are going to come in, they're not going to have a GitHub account. So I got to make a GitHub account. But there's a step where I need to link their GitHub account with their Google account that they have from school, like their student email address. So I know who's who. And so I made this year, I knew I wanted to have this journal. And so I used that as an opportunity. I was going to have this website that was going to be not a static website. So I said, well, I can have this site that can authenticate you to both GitHub and Google. So when you first come to this website, you will have to type in your GitHub password and type in your Google password, but then the site knows who you are. I am GigaMonkey and I am Peter Seibel at berkeley.net. And then it can put an entry in the database that says these two things go together. It also can, when I run it, let's see, get this set up. I'll just go. Oh. Trying to get it. All right, never mind. Oh, here we go. Yeah, so when I first come in, the beginning of the year, it'll look more like this, where it'll just find all my classes in Google Classroom. I guess I don't use Google Classroom next year. I won't have to do this. And then I say, okay, this class is actually AP CSA and it's meeting period 3 and it's in this room. And then I add it. And so that adds it to this system. And so now I have a class. And then as kids come in, authenticate to Google, it says, oh, you're that kid. And now I know your GitHub and I know who you are. But once we get past that setup at the beginning of the year, what this is really for is this journal system where I can make prompts and they write stuff. So a lot of it, what I used it for were these reflections that I had them write every week. So the prompt was always the same, but this one was optional because it's the end of the year. But like earlier on, the prompt would have been write 250 to 350 words about what you learned this week. And basically I just wanted them to think for like half an hour over the weekend about what they've been doing. And then I can look at those and what I actually look at, what do I look at? That's the data. I guess I can look at, I can look at the responses. So I can see like what kids actually wrote in their journal. Again, this could be a Google form, but doing it this way, it's like in a database and I know exactly when it was submitted. And so I can like automatically grade it. Like if it's not in on time, you lose points and I don't have to like spend any time figuring that out. Computer does it for me. It supports code highlighting and markdown, like normal markdown that everyone uses. And I can look at like one kid's journal, or I can see their whole journal, all the things they've written. And then some of these are prompts that I do in class, where's a good one? All right, like I asked, what's the difference between a void and a non-void method? And then I have a board view here that they all have a pseudonym in the system. And so I can just put this up on the screen and then pick out certain ones and say like, this is a great explanation, or this is a little bit off, whatever it is. So just another way to like get some material to talk about. Okay. So like the whole thing about journaling is not so much about technology. That's just like a slightly interesting pedagogy thing that I got from a great biology teacher who just retired last year. But that was the purpose of this site. Like I said, it also lets me link them account because kids choose GitHub names like this, which is not that useful when you're trying to figure out who it is. Though by the end of the year, I know kids' GitHub handles probably better than I know their last names. Like I know their first names from talking to them, and I know their GitHub handle. This one is a little bit different. So for those of you who have done any web development or whatever, these are the tools that I use. It's an actual dynamic website. It's running on Amazon. I use this Better SQLite 3 JavaScript library to talk to SQLite, which is an tiny embeddable database. And I use, in this case, Passport to do that OAuth dance. Passport's a library. So this is interesting if you're thinking of building something like this. If you don't know what any of this stuff is, don't worry about it. The help queue is actually the first thing I built 2 years ago when I was a volunteer. When the teacher one of the teachers I volunteered with used like a spreadsheet, a shared spreadsheet that she'd put up on a big screen and the kids would enter when they needed help. Or some kids would just like put their name at the top of the list or whatever. And I'm like, that's chaos. So I made this thing where you basically just put in, building a website, submit it, and then it goes at the bottom of the queue. These obviously are ones that were left over from the end of the year. And so, which I either never closed or never even got to. So that's why it's been open for 414 hours. But it's just a reasonable way. There's a view that I put up on the big screen that's bigger so I can see it across the room. And several of the other teachers in the CS department use this for managing their help stuff. So you can see what it's for. Built it in a similar way, except I use a different JavaScript library for talking to SQL, which was bad. So if you are going to build anything using SQLite, definitely look back to these slides and pick the right one, which is the one that's called Better SQLite. And then this is the last thing I need to talk about. This is the rubric server that I've been talking about off and on. So this is solving the problem of, okay, I just had 79 kids write 6 different classes that are supposed to extend each other, whatever, and now I need to grade them. And there's no tests because I didn't even let them run the code. The code may not even compile, but I can still eyeball it and see if did they get the basic idea? And so the way this works is for a given assignment, I create a rubric that's stored in, you guessed it, a text file, probably JSON, that lists all of the things I'm looking for. And I look at these and sort of figure out what, it's kind of like the chief reader making the scoring guide for the exam. I see these are the things that I care about. And then each of these dots is one student. And this is anonymized. So I don't actually know whose code I'm grading, but I look at these and then I go through and I can just tick these boxes. And, so this one doesn't redeclare precedence, like where the rubric is, I want them to not redeclare precedence, which I guess I counted this as a declaration. I don't know what's going on there. And at the end, one, is not shown here, but initially these bubbles were not filled in because I hadn't graded them yet. So I could sort of see my progress. And then eventually I get through them all. It's telling me what the grade is on a 1 to 4 scale. This one is quite low because they didn't finish. And then I think I hit work and it dumps out all of the grades in a format that I can import into my grading system. So that's the teacher view. Sorry. Trying to just get back to the slides. I should have opened it in a new tab. Oh, come on. Huh. Sorry. Oh, right. And as you notice, I'm just running this on my laptop. Sorry, I want to show you. Where'd it go? Oh, sorry. The links, we'll get to the link in a sec. Okay, so grading things that can't be auto-graded. This one is built in a little bit of a different way. This is basically just like a local thing that I run. That server has an endpoint that dumps out the grades. You just saw that. So that was the teacher view. And then I can take these rubrics, and right now I just export them to the journal server because that's the server that knows who the kids are. And so they all have one URL and it knows who they are and it shows them their rubric. So this is actually my daughter who was in my class, and I got her permission to use her rubric. So I can show you what it looks like. Of course, she did great. And so you can see these are the boxes that I ticked. It shows her her code, shows the ones that she missed. If I left a comment, like here, I left a comment on this particular thing. And so the kids can see how I graded their assignment. So right now it's a little bit of a kludge that like I have this server that I run on my laptop to grade it, and then I have to export it and push it to this other server. Which kind of brings me to this. I have too many lightsabers. So my project for this summer is to consolidate a bunch of these tools probably into maybe just one website that does all of this stuff. I might leave the help system separate because other teachers use it and they don't need all of this mess. But anyway, but this is the great thing about the teaching life is that I get this couple months in the middle of every year to try and like clean everything up and consolidate and rebuild for the next year. It's not like during the year, it just sort of accretes and gets more and more messy. And I just keep the thing running and then I get to this. So these slides you can look at your leisure. It's just a list of all the stuff that I used, which is a lot. And now we just have 20 minutes for questions. I guess I didn't. So yeah, just put your questions in. I know people probably have some more questions about how to use GitHub. I can probably show you what a code space looks like if you want. But put your questions in, or actually at this point, if you want to unmute, and it'd be nice to hear someone's voice other than mine. So maybe unmute and ask.
I'll start us off. First, thank you, Peter. Amazing, truly amazing work. So much of what you have is things that I've been looking for. I guess my question is kind of concretely like, what would be the actual steps we'd take to get started with some of these things? Like, for example, how are any of these tools, is the code on your GitHub? Some of them, all of them? What would the
Yeah,
process actually be like for, especially because a lot of the people in the room haven't used GitHub. So like, how much experience would you need to even think about tackling bringing some of these things in? And then also, what would that process look like?
yeah. So it is all on GitHub. However, the actual repo is private because it has all the assignments in it. As my kids are kind of clever and they'd probably figure out how to find the assignments. That some point I'll probably try and split that a little bit. So there'll maybe be one repo that contains all of the infrastructure, which is content neutral, and then another private repo for like actual content, But I have added a couple of you to the repos. I can add you as a collaborator if you just want to see it. I guess the little bit of the bad news here is like you kind of got to build your own lightsaber. Like you're free to take this code, but it is not designed. It is not shrink wrap software that is like ready to go. It is highly idiosyncratic, written by me to do what I want kind of code. I didn't even talk about like the markup language that I told you about. Like it's implemented in Common Lisp because I wrote a book about Common Lisp. So like good luck with that. Though I can recommend a book if you want to try it. So yeah, like so I'm happy to like give you access to the code so you can look at it. And happy to like give you some pointers if you want, if you're a brave soul who wants to try and take some part of it and get it running. But yeah, in some ways, I think my message here today is kind of where it's like, there's real value to building these things. And some of the value, some of the value is that it like, because we teach computer science, it's like good practice. And like part of the reason a lot of it is written in JavaScript was probably because it's on the browser, but also because I was teaching a JavaScript class. And I'm like, let me actually write a bunch of JavaScript. but the other value is that you get tools that work the way you want. Sorry, like I have very particular ideas about like how I grade things and how those grades flow into my grading system and what eventually lands in the grade book. And I can make them happen the way I want with my tools. So anyway, that's a little bit of a digression from your question, but yeah. So if you want, just shoot me an email and your GitHub handle, and I can add you to the repo. You have to promise not to like push commits to it because there's no way to add you to a private repo without giving you the ability to write to it. But it's version control. I can tell if you did, so just don't. And if you are totally new to GitHub, I would say the first thing you should do is just make a GitHub account. I mean, my ninth graders do it, so you can probably handle it. And I'm happy to answer questions on the mailing list or whatever for people who are trying to get up to speed on that. All right, while someone else is working up the nerve to ask a question. So here's what happens on Berkeley High CS is the organization. This is my repo, right? It's named for my username. That's my username. And under the code button, which is normally where you go to like clone things, I choose code spaces and I can create a code space on main. And so this is like going to the store and buying a computer and turning it on, except it comes pre-installed with, it might take a little while to come up, but it comes, like I said, pre-connected to my GitHub repository. So anyway, that might take a second, but I can show you what it looks like once it starts. But someone else should unmute, see what's on your mind.
Does anyone on here use GitHub Classroom?
I used it way back pre-Code Spaces, and then I switched to Replit, RIP. At the time, it was relatively helpful. And if there's specific questions, and if no one else has used it more recently, I'm happy to field some. But it did it like made a repo per student per class. It was like they click one button. Well, you make the starter template repo, and then they click a button that auto forks for them. And then there was even way back then, there was already a checkbox to make it so that it would auto set up the pull request. So Peter talked a little bit about how he had played around with having the pull request that you could give feedback on. And so that was kind of their thought process as well, to make that auto set up with a pull request. It did, especially back in the day, it requires your students to like actually make the commits themselves and do the pushes themselves, which Peter's system cleverly gets around by making the play button do that. And that was a struggle, at least for a lot of my beginners. Just
and I
like
will
the
say,
mechanics of GitHub.
When we get into code spaces, there's definitely some kids who I mean, struggle probably because it's sort of abstract and invisible, but this idea of like, especially because the code space is on the website and you got to that page on the website from GitHub. So it's like, I'm on GitHub. I've done the thing on GitHub. It's like, no, you've done it on a computer. That's like, and now you need to press a button to make those changes go to like the real GitHub so I can see them. And the only saving grace is that I can tell whether there are, I can say, I have no changes from you since last Friday. Where are they? And I can, walk around. But it is definitely, if you do the code spaces thing, you definitely can plan to spend some time making sure kids understand the life cycle of like make changes, commit them, and then sync them. But which is good training though, because this is how the world really works. So like, especially if you're teaching at all, CSA or anything more advanced than that, like that's a thing they need to learn, independent learning job. All right, I don't know why this code space is taking forever to start. It's usually not this slow.
It's probably because you're on Zoom. Zoom just takes up so much of your memory.
That could well be. No, finally connecting. So it's like it sort of comes online in bits. It's like kind of alive here. So this is just a normal Unix terminal. You can see the files over here. It's not quite connected to the Git repository yet. Anyway, this is, so this is like the editor. You edit code, and then I think this one is set up. Yeah, so this is the like thing that lets you run GUIs. Maybe. All right. So anyway, this is what CodeSpace looks like. So do I have a... No, I don't know that I have any GUIs in this particular repo. Anyway. Yeah, I would agree with that. Like, sorry, Beryl, were you talking about code spaces are harder than Replit or Classroom?
Both.
Yeah, I mean, Replit, its great virtue, I guess, is that it's like pretty intuitive. It also lets kids, they can like work collaboratively by just all literally editing the same file at the same time, which makes a lot of sense. The kids are used to Google Docs, but makes me like break out in hives when I see people developing code that way, because it's like it's hard enough to debug code that stands still, like debugging code that 3 other people are typing in. That's insane.
Yeah. I mean, I do think GitHub in general, both of those are harder to use than Replit, but they are what's used in industry. So if if you have students who really want to go into software development, they should learn how to use them.
And you can get, yeah, I mean, I would say Replit's for me is like intermediate between, like for many things you would do in Replit, I can just do them in my coding environment on my website. And then there's things you can't do there that you could do in Replit. And then next step up is code spaces, which are a little harder to use, but also more powerful. So, but yeah, it's a bit of a trade-off. And I think Replit may have, I think the thing that killed me was like 2 years ago, they used to have a code formatter and then they took it away. And I'm like, I cannot use, as you know, a tool that does not have a code auto formatter. And I think it's back now. So that problem has been fixed.
I think they just moved it and hid it, Peter. Because
Maybe.
I remember distinctly when it like went away and then I found it like a week later and it's like, why did you hide it there?
Yeah.
And then it's back in a visible way now.
Yeah. I mean, I love actually, I almost had a panic attack last summer when I was building the Java version of my website, because like VS Code has a built-in code formatter, but only for JavaScript. And so I was like, oh, it just handles it for me. Then I'm like, oh, wait, it doesn't know how to format Java. So then I had to like figure out how to wire one in. But it can be done. So that's another thing is like the VS Code library is very flexible and you can do all kinds of stuff with it. All right. Cool. All right. Well, thank you. I'm happy to stick around while sharing code. It hasn't been. So the question is, how problematic is students sharing of code? It sounds like I've got some ability to do forensics. So for me, the GitHub, just the Git, like the fact of Git. And someone asked a while back, I said something about, I have tools for working with GitHub to see things. It's mostly just Git itself, because Git is a history of everything that's happened. And particularly in my coding environment, where everything that's happened is every time they've hit the blue arrow to run their code, right? If they run it at all, I can see what the code was at that point, and I know what time that happened. So it's pretty easy for me to, see the series of changes, and I can see what did the file look like at that change. So if I see, like, that's how I saw that code like migrate around the room, I forget whether that was a test or just some code, like a project, but like, there's a chunk of code that as I'm looking at the code to grade it, I see, wow, there's this same chunk of code. And usually it's something that's idiosyncratic in some way. And I'm like, well, it's unlikely that everybody would write it exactly that way. But then I can see where it started and be like, oh yeah, that kid who's a superstar wrote the code. Oh, and then his friend got it next. And then the kid who's next to them got it next. So it's still, intuition and paying attention. And there's no, I think I did one time more to make a point. I had a pair of students who were really copying off each other a lot. And so I did a sort of pairwise comparison of all the pairs of students in the class and how similar, textually similar their code was to show that these two kids' code was way more similar than anyone else's. So that I could email their parents and be like, look, this is not my imagination. But that's just because Git gives me all that history and I can write programs to pull it out and analyze it. Do I allow the use of AI tools? I do. In this sense, or I do not, like my default position is you may not use AI tools. However, there are times when I encourage them to, and in my advanced class, I think I kind of said they can use them, but the deal is they have to send me the link to the conversation. So that's assuming like ChatGPT. If they're using Copilot or something, I don't really know how to get a trace of what they did, but I use ChatGPT all the time. Like built a lot of this website with like, hey, GPT, write me a little like scaffolding code to use this library that I've never used before, and then I know where to take it from there. But detecting AI in code is also probably many of you have seen, like sometimes not that hard. I don't know, there may be lots that slip by me, but I definitely see some code that's way more sophisticated than I expect. And then I write some part of it up on the board and ask the kid to explain it to me, and they give me a blank stare, and then I'm like, you just wrote code like this on the test. Now you can't explain it. That makes me think maybe you didn't write it. And they usually tell me, yeah, that's what happened. Summative assessments live on my site. How do you mean by secure? Like secure in that they can't like flip to another tab and cheat, or?
Yeah, the answer is yes.
I mean, we mostly work on Mac, so we don't have like the lockdown browser on Chrome or something, Chromebooks. You might, I guess, probably didn't see enough of it, but I did make the one difference between assignments and assessments is the background color of assessments is like a bright pink, so that I can walk around the room and see if they have like an assignment tab that might have some useful code open, and then I'm like, you should be just on the assessment tab. It should be pink. So that's, I don't know. This is no more advanced than walking around the room and making sure kids don't have like a crib sheet out. And then I catch a lot of stuff post facto and get. All right, I think people are winding down. Beryl, you want to say something?
No, I was just I love the use of Otter AI in this presentation too that some people had up. So AI is definitely useful.
All right, well, thank you all for coming. Feel free to, I don't know, post questions on the mailing list if you have further questions, and I'll post the recording once I get it downloaded.
Thank you. This was great.
Awesome. Thanks,
Thank
folks.
you so much, Peter.
Thank you very much, Peter. Very kind.
Bye, everyone.
Literal hero. You're a great one.
Thank you, Peter. Have a good day.
You too.